Hello, this is part 2 of section 2.2 of my lecture. Let's go ahead and finish up this packet. Now we're going to talk about even and odd functions. The function f is an even function if f of negative x is equal to f of x. So the right side of the equation of an even function does not change when you replace x with negative x. The graph of an even function is symmetric with respect to the y-axis. A function f is an odd function if you take f of negative x and it's equal to negative f of x. So the right side of the equation of an odd function changes its sign if x is replaced with negative x. Alright, so let's look at this problem. We're going to determine whether or not the function h of x is equal to x to the fifth plus 1. We're going to determine whether or not it's even, odd, or neither. Alright, so to check for even, you're going to set x equal to negative x. Okay. We get negative x to the fifth plus 1. That comes out to be negative x to the fifth plus 1. So in order for this to be even, this has to be equal to our original equation, our original function. And it's not. So this is not equivalent to our original problem of x to the fifth plus 1. So this is not even. Let's check to see whether or not it's odd. So we're still going to replace x with negative x. We already know that it's equal to negative x to the fifth plus 1. So to be an odd function, the result must have the opposite sign from the original equation. Alright, so what do I mean by that? So we know that the original equation is this. The opposite signs will be this. Okay? So our result, this must match up to this. And it does not. So this must match. And it does not. So this is not odd. Okay, so this is neither even or odd. Okay. Let's do another problem. We have 2x cubed minus 4x. We want to see whether or not it's even or odd or neither. So for even, once again, we're going to set x equal to negative x. We get h of negative x is equal to 2 times negative x cubed minus 4 times negative x. This turns out to be negative x cubed plus 4x. In order for this to be even, it has to match our original equation, our original function, and it does not. It's not equivalent. So this is not even. Now we're going to check to see whether or not it's odd. Once again, we set x equal to negative x. We already know that that's equal to negative 2x cubed plus 4x. It has to match the opposite of our original equation. We know our original equation is 2x cubed minus 4x. If we change the signs on the original, we get negative 2x cubed plus 4x. So these two must match, and they do. They're the same. So, since that's the case, this is an odd function. So now we're going to talk about piecewise functions. A function that is defined by two or more equations over a specified domain is called a piecewise function. In this first example, we got c of t is equal to 20 when t is in between 0 and 6 inclusive, and is equal to 20 plus zero point 0.4 times t minus 60 when t is greater than 60. So depending on the value of the t determines which equation we use. Depending on value of t determines which function to use. Alright, so let's calculate c of 40. c of 40. So c of 40 lets us know that t is 40. T is 40 falls into this first interval here. So when t is 40, our function c of 40 is equal to 20. Okay? The next one says find c of 80. 80 is greater than 60. So we need to use this function here. Whenever we see a t, we're going to plug in 80. 80 minus 60 is 20. 20 times 0 0.4 is 8. And we get 28 as our answer. So c of 80 is equal to 28. So now let's talk about how to graph a piecewise function. We graph it based off of the value of x. So in this problem we have f of x is equal to 3. That's when x is less than or equal to negative 1. And f of x is equal to x minus 2 when x is greater than negative 1. Alright, so remember we said f of x is the same as y. So let's graph this first one. Y equal to 3. Y equal to 3 is a horizontal line. No matter what we plug in for x, y will always be 3. In this case, we have to plug in values of x that are less than or equal to negative 1. Okay? Less than or equal to negative 1. So we can have negative 1, negative 2, negative 3. Okay, since negative 1 is included, when I graph this point, I'm going to put a closed circle. I can't have anything greater than negative 1 for this particular function. It can only go from negative 1 below. Alright, so let's go ahead and graph this. We're going to plot the points negative 1, 3, negative 2, 3, and negative 3, 3. And we can keep going, but our graph has has to start from negative 1 based off the stipulations. Oops, I didn't mean to erase that line. Let me try to draw a little straighter. There we go. I'm not really good at drawing. Alright, so that's my graph. So now let's graph the other line. Y is equal to x minus 2, and that's for values of x greater than negative 1. Greater than negative 1. So I'm going to put negative 1 on here even though negative 1 is not included. And then I'm going to go everything above negative 1. So I got 0, 1, and 2. When I plug negative 1 back into the equation, I get negative 1 minus 2, which is negative 3. When I plug 0 back in, I get negative 2. When I plug 1 in, I get negative 1. And when I plug 2 in, I get 0. So even though negative 1 is not included in the stipulations, I'm going to put it in, graph it anyway, but I'm going to put an open circle. And that lets me know that that number is not included. Alright, so let's go ahead and graph these points. We have negative 1, 3. Once again, I'm going to put an open circle. 0, negative 2. For the rest of the points that are included, you can put closed circles. 1, negative 1, and then 2, 0. So this is my graph. Oh, that was really crooked. There you go. All right. So that's a piecewise function. As you can see, it's done in pieces. All right, so let's look at another problem. We have negative 2x minus 1 when x is less than 2. And the function is equal to x plus 4 when x is greater than or equal to 2. So let's go ahead and graph this first one. We're going to make our table of values. And x has to be less than 2. Less than 2. So I'm going to put 2, even though it's not included. I'm just going to put an open circle there. We got 1. We can put in 0. We can put in negative 1. So when I plug in 2 back into this negative 2x minus 1, I get negative 3. Oh, no, I don't. Sorry, negative 5 is what I meant to say. Negative 5. And then when I plug in 1, I get a negative 3. When I plug in 0, I get a negative 1. And when I plug in negative 1, I get a 1. So all I did was plug it back into this first function here. This right here. All right, so let's go ahead and graph these points. 2, negative 5 will be here. I'm going to put an open circle. Oh, I'm sorry. Not over there. On the other side. Right here. 2, negative 5. And then 1, negative 3. 0, negative 1. And negative 1, 1. So as you can see, the points fall into a straight line. All right. So now let's look at the other function. So this was for y is equal to negative 2x minus 1. Now let's look at y is equal to x plus 4. And this has to be for values greater than or equal to 2. So you got 2, 3, 4. When I plug 2 back in, I get 6 for y. When I plug 3 back in, I get 7. When I plug 4 in, I get 8. Okay, so we're going to graph these points. 2, 6 will be here. I'm going to put a closed circle because 2 is included. 3, 7 will be here. And then 4, 8 will be here. And then we can go ahead and draw the line. All right. So now we're going to talk about how to simplify a difference quotient. If you go into Canvas, I did put up another video, a YouTube video for difference quotient. I just tried to find an additional resource because this can be long and messy. So I'm going to go ahead and do this problem. We're going to do it piece by piece. So the difference quotient is f of x plus h minus f of x divided by h. H cannot be equal to 0. So what you're going to do is you're going to have an equation or a function. F of x is equal to negative 2x squared plus x plus 5. We're going to find and simplify the difference quotient. Alright, so the first thing we're going to do is figure out f of x plus h. So that means whenever we see an x, I'm going to substitute it with x plus h. And now we have to calculate this out. This x plus h squared, you just write it out twice, and then we have to FOIL it. We got to multiply it out. Okay? So this will be x squared plus xh plus xh plus h squared. I'm using the foiling method, so make sure you know that. Now I'm going to go ahead and combine this. The only like terms we have in here is xh times, xh and xh. So this would be 2xh. You just add them together. And then you bring the rest of this down. a squared in here. Here we go. All right, so now we're going to multiply everything in parentheses by -2. So this is -2x squared minus 4xh minus 2h squared. And then you got the x plus h plus the 5. Okay. So if you look at this, there's nothing that we can simplify. There's no other like terms in here that we can combine. So this is my fx. This is my f of x plus h. So now let's put it together. So the next thing we have to do is take the f of x plus h and subtract off our original function of f of x. So I'm just doing this numerator part here. This is what I'm doing here. Alright, so I already know I have -2x squared minus 4xh minus 2h squared plus x plus h plus 5. I'm going to subtract off the original function of -2x squared plus x plus 5. Now be careful here because you have a negative in front of this set of parentheses. So that means we're going to change all the signs in parentheses over here. So this first part stays the same. I'm going to change the signs here. So instead of having a -2x squared, I'm going to have a positive 2x squared. I'm going to have a minus x and I'm going to have a minus 5. So now let's see what we can cancel out. I have a -2x squared and a 2x squared. If I add these together, that's 0. I have an x and a -x. When I add these together, that's 0. I have a 5 and a -5. When I add these together, that's 0. So I simplified it. I don't think there's anything else I can cross out. I'm left with -4xh minus 2h squared plus h. But now we're not finished. We still need to do the last part. We need to divide by h. Okay, so we're going to take this and divide it by h. So we're going to take -4xh minus 2h squared plus h divided by h. And now we can simplify. You can split it up so it'll be easier for you to cancel out. So here these h's cancel out. I'm left with -4x. An h would cancel out with an h here. I'm left with minus 2h. These h's cancel out. I'm left with a 1. So this is my final answer. -4x minus 2h plus 1. All right, let's do one more. We have f of x is equal to x squared plus 3. This one is a little simpler. Let's go ahead and figure out f of x plus h. Whenever I see an x, I'm going to plug in x plus h. We're going to go ahead and FOIL this out. I'll write it out twice. We already FOILed this out previously, so I'm just going to write it out. We get x squared plus 2xh plus h squared plus 3. So if you're confused on how I did that, just go back to the previous problem. Now we're going to take this and we're going to subtract off the original function. We're going to take x squared plus 2xh plus h squared plus 3. We're going to subtract off x squared plus 3. I put it in parentheses. So now let's go ahead and simplify this. This would be a minus x squared and this would be a minus 3. So now let's see, what do we have in common. We have an x squared minus an x squared. Those turn out to be 0. And then 3 minus 3 also turns out to be 0. So I have my numerator as 2xh plus h squared. Now the last part is to divide by h. Divide by h. So you can split it up if you want to. Divide each one by h. So these h's cancel out here. I'm left with a 2x. And this h would cancel out with an h here. I'm left with an h. So my final answer is 2x plus h. All right, that's the end of this lecture.